Hello friends, in this video we will prepare the compound Sodium Nitrosyl Cyanoferrate, more commonly known as Sodium Nitroprusside. Sodium nitroprusside has iron with 6 valencies, 5 of which is occupied by the cyano group and 1 occupied by the nitrosyl group. This is used in medicine as an antihypertensive medication for hypertensive emergencies. The chemicals that you will need for this preparation are 40 grams of potassium ferrocyanide and 64 milliliters of concentrated 67% nitric acid. 40 grams of potassium ferrocyanide was placed in a beaker with a stirring bar inside. With the stirring turned on, 60 milliliters of distilled water was added to it using a graduated cylinder. It will take some time to dissolve. The solubility of potassium ferrocyanide in water is around 330 grams per liter. Some heat was applied using a hot water bath to let everything dissolve. Eventually, we are left with a clear solution that has a golden yellow color. Next, 64 milliliters of concentrated nitric acid had to be added. I learned from my experience that temperature should be kept to a lower side, otherwise oxides of nitrogen will be produced as side reaction. So to prevent that, I placed the nitric acid in a separatory funnel and added it very slowly to the ferrocyanide with stirring. Now as you can see, no more nitrogen oxides are formed. What's happening here is one molecule of potassium ferrocyanide reacts with 6 molecules of nitric acid to produce the nitrosyl cyanoferrate ion. Along with that, potassium and ammonium nitrates are formed. So carbon dioxide is liberated. Once the acid addition is complete, the mixture is gently heated on a water bath until the reaction is complete. You can check for the completion of reaction by looking for residual ferrocyanide ion. This can be performed by adding few drops of the test solution to iron 2 sulfate solution. If you get the Prussian blue color, you can see as here, it means that the reaction is not complete and you need to heat for a longer period of time. Here I have arranged beakers with ferrous sulfate solution to assess the completeness of the reaction. The reaction is said to be complete when there is no more Prussian blue color formed. Instead, clumps of bluish green mass is seen, as you can see in the third beaker here. Allow the solution in the beaker to cool down and then let it stay for 1 to 2 days and then filter the crystals of potassium nitrate, which will separate out. Here you can see the crystals of that. Now to the residual solution, sodium carbonate was added to neutralize the acid. This can generate a lot of bubbles and together with the tar-like substance, it can produce lot of foaming. So the addition of sodium carbonate should be slow and in small additions at a time. Since I anticipated a lot of foaming, I decided to transfer everything to a very large beaker. Here I am using a 2-liter beaker. Here we are doing a double displacement reaction, causing the sodium nitrosyl cyanoferrate ion to be formed. Care should be taken not to add too much of the sodium carbonate at once. We just want the neutralization point attained. Once that is attained, the solution was filtered. I filtered using a vacuum filtration method. I am using a Buckner funnel and you can clearly see the solution coming down from the funnel has a beautiful red color to it. Apply vacuum and suck out all the liquid present in it. Once all the liquid is obtained, we wash the Buckner funnel with some amount of water and that was also transferred to the beaker. The total volume of beaker is now around 150 milliliters and we boil down excess of water until about half of the water, more than half of the water was removed. After removing about 2/3, we are left with around 75 milliliters of the liquid and into that an equal volume of ethyl alcohol, which is around 96% ethyl alcohol, was added. This should be added only after cooling down the solution to room temperature. This will cause all the dissolved potassium nitrate present in the solution to crash out, and we will allow this ethyl alcohol to Mix around with the solution for around 15 minutes to ensure complete precipitation of the solid potassium nitrate. And here, after mixing it for a few minutes, I let the solution sit for 1 or 2 hours, and you can see the crystals of potassium nitrate settling on the bottom of the beaker. Now the solution was filtered. Again, I'm using a Buckner funnel and a vacuum filtration setup. Once everything is filtered through, you can see the white crystals of potassium nitrate to a beaker trapped in the half of the volume was evaporated down, and then the solution was transferred to a crystallizing dish and was allowed to stay in room temperature for 24 hours and then was placed in refrigerator for 24 hours. Finally, after 48 hours, the crystals formed was filtered. Again, I'm using the Buckner funnel and vacuum filtration setup. You can see the red colored crystals in the liquid. Once the solution was filtered, the beautiful ruby red colored crystals of sodium nitroprusside is visible now, and these are the crystals. Now this vacuum was kept on and the crystals were allowed to dry under vacuum. Now we will do a simple test to identify the sodium nitroprusside ions. Here we have a sulfide solution on the left side, and on the right side we have the sodium nitroprusside solution. We will add few drops of sodium nitroprusside to the sulfide solution, and immediately you observe a purple color developing due to the formation of a complex. This is actually a confirmatory test for sulfides in the qualitative analysis. So that's all in this video. These are my Patreon supporters who are financially supporting me, so I am able to purchase new chemicals and equipments required for doing new videos. You can also support me via Patreon or PayPal. The links of both of them are in the description. If you are new to this channel, click on the subscribe button and the bell button for notifications, and I will see you in the next video.